Hello class, let's review Unit 4 about energy. First of all, what is energy? Energy is the ability of an object to produce work, la capacidad de un objeto para realizar un trabajo. And work can consist of movement, temperature, or light. Second, we need to know the fundamental principle, the conservation of energy, which tells us where energy comes from. That principle says that energy is not created or destroyed, it is only transformed. El principio de conservación de la energía. La energía ni se crea ni se destruye, solo se transforma. It tells us that it all comes from the Big Bang and that all energy forms come from a different energy form. They are just transformations. As the third section in our unit, we need to learn all 6 forms of energy, 6 formas de energía, y tenemos una frase con la cual nos podemos acordar muy fácilmente. Menudo núcleo termal que elijo lucir. Mechanical, nuclear, thermal, chemical, electrical, and light energy. It's all energy, it's just different forms. Mechanical energy, which it's the capacity to produce work as movement, can be separated into kinetic, when it's movement and you see the girl on the right throwing the ball, and as the ball falls, its kinetic movement energy increases, or potential energy, which is the position of the ball, that it can move. Así que la energía mecánica puede ser dividida entre la energía cinética y la energía potencial. La cinética es el movimiento, la potencial, la posición, porque puede moverse si está en determinada posición. Then if we want to talk about nuclear energy, in class we saw that all matter, life or dead, is made up of atoms, and really big atoms have sometimes lots of energy inside the nucleus. If we split the nucleus, we free that energy that is transformed into heat that we can use, and that's nuclear energy inside the nucleus of big atoms such as uranium. Then we can talk about thermal energy. When molecules vibrate, for instance, if you rub your hands, you will see that temperature rises. Your hands get warmer when you rub them. Then chemical energy, this is very important, is stored in the molecules, the combinations of atoms of different substances. Food has chemical energy, our muscles or cells have chemical energy, batteries have chemical energy, and we transform that chemical energy in other types of energy. Then we have electrical energy that consists of moving electrons from an atom to the next. We saw in class how an atom is like a little solar system, with the sun in the middle being the nucleus and the planets orbiting around the sun being the electrons. And last we have light energy. Mostly we have natural energy coming from the sun as solar radiation, but we also can have artificial light sources. All those forms of energy can be transformed, and that's how the world works. In here you can see some of the transformations that we have discussed in class. The first picture, you see that lady that is filling up the tank of her car, and so the car has an engine. Los coches, los aviones tienen motores que transforman la energía química que está almacenada en los combustibles, como por ejemplo la gasolina, la transforma en energía cinética y energía térmica. So those fuels are burned inside the engines to produce different types of energy. On the second picture, you see appliances and electrodomésticos, appliances. And electrodomésticos use electrical energy when you plug them, and that electrical energy in the electrical engine are transformed into the electrical motor, is transformed into thermal and kinetic energy, depending of the type of motor they have. And on the third picture, you can see the solar panel, and it just receives radiation and transforms it into electrical energy. Down here, we can see a picture that represents a very important transformation. The sun produces light energy, radiation, and that light energy is transformed by plants and by different bacteria into chemical energy through photosynthesis. Then other living things eat those plants, those producers, and transform the chemical energy in the plants into different types of energy. When we consume food, meat, or vegetables, we consume calories or joules, and that gives us the ability to move, to heat up, to grow, and also to accumulate mass, to accumulate muscle and fat that contains chemical energy. En la foto inferior podemos ver una transformación que es esencial para la vida. El sol nos proporciona energía luminosa, energía lumínica, que es utilizada por plantas y por algunas bacterias mediante la fotosíntesis para producir energía química que almacenan en su biomasa. Cuando son consumidas por otros organismos vivos, esos organismos vivos obtienen calorías, obtienen kilojulios, que es una medida de energía que les permite moverse, mantener la temperatura vital y también crecer o acumular grasa, acumular músculo, que sabéis lo que está dentro de la grasa y del músculo, energía química. As the fifth point, we saw that energy comes from different sources, las fuentes de energía y su clasificación. And those energy sources can be classified as renewable, which can be newed, which can be produced as new sources. And we saw that we have four types: biofuels, hydroelectric energy sources, eolic or wind, and solar energy. Biofuels, fuel means combustible, fuel is combustible. We have, if it's solid, we call it biomass. If it's liquid, bioliquid. If it's gas, we call it biogas. They contain chemical energy, and that chemical energy is burned at power stations, so that when they're burned, it produces heat that transforms water, liquid water, into water vapor, and that vapor is used to turn a turbine, and as the turbine turns, it produces electricity. Cuando quemamos un combustible, que es un biofuel, un biocombustible, generamos calor que se utiliza para transformar el agua en vapor de agua, y ese vapor de agua mueve una especie de ventilador que se llama turbina que genera electricidad. The second type is made by water, the hydroelectric energy, and in here we have a reservoir, un embalse, that is held back with a dam, as you can see in the picture, and as the water is let through a little gate, through that little canal, the water is going to turn, rushing through again a turbine and produce electricity. Then we have down in the bottom left, we can see the picture of the typical turbines, the wind turbines, los aerogeneradores que vemos en los laterales de muchas carreteras españolas. And as the wind turns the turbine, they produce electricity. It's a very straightforward process, but it only works when there is wind. Then we have solar panels. Again, radiation can be used to produce heat and electricity. The second type of energy sources are the non-renewable, las no renovables. And we have a little sentence to describe them. La Coca-Cola tiene gas, tomo solo una. Coal, natural gas, petrol, uranium. Coal, carbón. It's created from prehistoric plants after millions of years of being buried under tons of dirt. And those plants had chemical energy. When it's stored as coal, it's turned into a stone, and that stone contains that chemical energy that can be burned at power stations. Again, when you burn, you produce heat, you turn liquid water into water vapor, and use that transformation to turn a turbine that produces electricity. Second, we have natural gas. Again, its origin is prehistoric plants and animals. It contains chemical energy. It can be burned at power stations, and again, as we burn, we produce temperature, convert water vapor, liquid water into water vapor, and use it to turn a turbine and produce electricity. And also we can burn it to produce heat at residences. Third, a source of energy which has been extremely important for the development of the humanity, and is petrol. It comes from prehistoric animals that got buried millions of years ago, and they got buried, material accumulated on top, and nowadays we can exploit that chemical energy that is stored in those prehistoric animals to burn it in engines. And last, we have nuclear energy, and as we saw, there are some materials such as uranium which are radioactive. We split those atoms so that they convert into different atoms, and lots of energy is released from the nucleus, producing heat that moves a turbine and generates electricity. Now let's talk about what happens when we overuse non-renewable energy sources. First, they are limited because they are non-renewable. Como son no renovables, son limitadas, se gastan. If we use them up, we won't have them, and evidently prices will rise, subirán los precios. Second and most important is pollution. Let's here talk mostly about two big global effects of the wasteful use of non-renewable energy sources. Global warming. When we burn fossil fuels, such as coal, natural gas, and petrol, we generate carbon dioxide, CO2. Generamos dióxido de carbono, que es un gas de efecto invernadero. That greenhouse effect, ese efecto invernadero, causes the heat from the sun to be trapped in the atmosphere. What happens if we have lots of heat in the atmosphere? That the poles will melt. And if the poles will melt, that ice will become water, the oceans will rise, we will lose lots of coastal zones, and climate will change. We'll have more hurricanes, we'll have more droughts, etc. The second effect is acid rain, because some fossil fuels such as coal may contain other substances such as sulfur. Sulfur can change the acidity of rain when it mixes with water. And if rain becomes acid, cuando algo es ácido puede quemar, and it hurts plants, aquatic animals, and even monuments. In here I have added a picture of climate change, of the greenhouse effect. As you can see, CO2 creates like a layer that traps solar energy and not letting most of it coming out of the sun. Okay, what can we do to protect the planet? We have the three R's: reduce, reuse, recycle, and they are in the correct order. Las tres R's: reducir, reutilizar, reciclar. Las tres R's, and they are in order. First, we must reduce, consume fewer things, buy fewer things with fewer less packaging. Second, reuse, reutilizar, use containers over and over, try to produce less waste. And last, recycle. If you cannot reuse it, put it in the correct bin so that it can be processed into new materials.